acids and bases. And I know a lot of people have done that when they did chemistry up to a certain point. So the first part probably will not be too challenging. What's an acid? Sorry? Proton donor, yes. How did it, say again? In the Brønsted-Lowry definition, yes. What was the first definition of an acid? It's not the stuff that you take, on a Saturday night. Sorry? That is a characteristic of an acid, pH below 7, and we obviously need to discuss what pH in this context means. What was the first definition of an acid? There was a guy called Arrhenius who defined an acid as something that gives off protons. Gives off protons. When it's put into, say, water. And also a base, it gives off, what does a base do? Gives off? Hydroxide ions. Gives off hydroxide. Yeah, that was the first definition of an acid. And then, as Anton rightly said, there came a new definition because this Arrhenius definition didn't work for all the things that people observed. So they came up with a Brønsted-Lowry definition. And they said an acid is a proton donor, which is basically the same thing as Arrhenius said, gives off protons. And the base is a proton acceptor, exactly. You're all familiar with that, more or less. Protons, these are just simply naked nuclei, positively charged proton. No electrons around, nothing whizzing around. Another definition? Is there another definition? Lewis. What did Lewis say?
E-pair acceptor is acid and base is E-pair donor.
Exactly. Lewis said an acid is an electron pair, and that's, the emphasis is on pair, electron pair acceptor and a base is an electron pair donor. You are not going to deal with a lot of Lewis acids and bases when you do biology. You will come across, when you, in the chemistry module, you will come across a couple of Lewis acids and Lewis bases, just to be forewarned. But quite commonly in in everyday biology or biosciences, they don't play, this definition doesn't play a huge role. Okay, so we have got a pretty good idea what acids and bases are, and let's just simply do a little, let's just use an acid. So one of the very common acids is hydrochloric acid, HCl. And here's a little trick for you. When we are talking about inorganic acids, usually by convention, we write the proton in the first place. So by writing it like HCl, it means, it indicates that this is an acid that can give off the proton. Because sometimes people ask me, how do you know whether this is an acid or a base? But this is from the convention. Writing the H in front means this is an acid. If I've got something like that, NaOH, sodium hydroxide, you see the H is not in front, the H is actually at the end, and that indicates that this is a base. So the base can give off the OH, the acid gives off the HCl. Makes sense? Yeah? Okay, so what does the acid, what happens actually if I put, for example, HCl into water? It almost completely splits. And it splits into the proton, that's why it's an acid, plus a chloride ion. Yeah? And this proton has the ability to do all sorts of weird and wonderful things. It can dramatically change the environment of everything. So, for example, a typical acid, an organic acid, where this trick with the H in front of doesn't really work. There are other conventions. But, for example, organic acid, like vinegar, will completely change the taste of your chips. Yeah? If you put the vinegar on it. People from the continent, like myself, will feel absolutely disgusted with this horrible habit of you guys putting vinegar on it. It has to be ketchup or mayonnaise on chips, right? And who is in favor of vinegar? Hands up. On chips. Who is in favor of ketchup? Who is in favor of mayonnaise? Who doesn't like chips? Sacrilege! Oh my God, how can you survive without fish and chips? Well, you see, it changes things completely. By the way, one of the main ingredients of ketchup is vinegar. Such that you know, you're all right then. Anyway, these protons have a profound effect on basically life, universe, and everything. Okay, so just carry on with a little bit of the conventions. Here we have an acid, and this acid is called, what happens, it dissociates into a proton and the chloride. Now I want you to visualize what's going on here actually. let's see whether we can do a little practical demonstration. And for that, I need an assistant, my son. Say hello to Sebastian. Sebastian? Come here. He's a bit shy. Do you know what he just said? He said you pay for that. Right. Now, imagine what we just said with the acid and the base. Daddy is the acid, and that's the proton. Right? And now I dissociate. Touch. Right? So, what am I now?
Nothing.
Nothing, I know. That's what everybody says, right? I'm a nothing. What is he now? What is he now? He has got a proton, doesn't he? He would be potentially positively charged, yes. He's got the proton. Could he give over the proton? Well, if he has a proton, what is he now? Acid. He's an acid, exactly. Could he give the proton to me? Right. What is he now? He has given off the proton. I received the proton. I now have the proton and the acid again. Right? If I give off a proton, I could accept the proton, couldn't I? Yeah, I could accept the proton. What am I? A base. Now I'm an acid. What is he? A base. What is he? What am I? Thank you. Thank you very much. Well done. So what we have got here, if you like, here we have the acid because it has a proton. Here, what is the chloride? It is? It is a base, exactly. Because it can accept the proton and potentially do it in reverse. Yeah? And because we are related to each other, and here the chloride and the hydrochloride are related, we speak of an conjugated acid-base pair. Or if you like, in a conjugated acid-base pair, the acid is the guy who has the proton, the base is the guy who doesn't, who is accepting the proton. Yeah? Makes sense. Okay, let's see if you got it. HOH, water, goes into H plus OH minus. Okay? What is the acid? What's the acid? HOH. Who thinks water is the acid? Okay. Who thinks something else is the acid? Oh, good. So this is the acid. What's the base? The OH minus, that's the base. So this is a conjugated acid-base pair again. Acid and base. Yeah? This was one of the questions in the exam last year where people really got into self-doubts and depression and, they thought, oh my God, what the heck is that? But with this definition, it's pretty clear, isn't it? Okay. Now, one thing that's quite interesting is that if you've got water, a proton on its own would never exist, because it is just simply a naked positive charge. So in water, what would happen is you've got this poor little proton sitting here, and a lot of other water molecules would react with that. So they would probably react in a way like that. Yeah? So you would probably have H3O+. But actually that's not that's not what happens. Usually you have this little proton sitting here, and you've got a huge shell of water molecules sitting all around it. It sort of shields this positive charge. But very often you will see this writing like that, and this is called a hydronium ion. Hydronium ion. Okay, here's another one for you guys. H3O+ dissolves into what does it dissolve? Into what? H plus H2O. You're absolutely right. Yeah? So which one is the acid? It's the H3O+. Which one is the base? The H2O. That's the base. What have we got? A conjugated acid-base pair, right? Wait a moment. You're lying. Because you just told me that in this case here, water is the acid and OH minus is the base. And now you're trying to sell me that H2O is the base. Did you hear that? No? Loud.
It's an amphoteric nature. It can act both as a base and an acid.
So, you are absolutely right. It is amphoteric. Water is amphoteric. It can either act as an acid or as a base. Because we have people here under age, I can't make any, rude comments about that, but in a way, the H2O is batting for both sides. Acid or base. Yeah? And we have that quite frequently, that compounds have this amphoteric, ampho means both, behavior. They can work as acids or as bases. Okay, another thing that I need to tell you is that we have compounds with this, like with this HCl. How many protons can this give off? 1. So it basically, this one proton can satisfy one base molecule. So it can bind to one base. And that's why we call HCl a monobasic acid, because it can satisfy one base molecule. Okay? But we also have other acids which could give off 2 protons. One for you, and one for my daughter Isabel. Say hello to Isabel.
Hi!
And one for you. So I have satisfied 2 bases. So you don't need to be a rocket scientist to figure out that a compound, for example, H2SO4, is a dibasic acid because it can satisfy 2 bases. Yeah? Happy with that? Can I have my lemons back? Oh, you. Okay, I'm now the acid again. We actually can even have tribasic acids, for example, H3PO4. That's also a tribasic acid. Okay, now here a quick check for you. I have a solution of a 1 mole per liter HCl. How many moles of protons and how many moles of chloride do I get? 1 molar of protons and 1 molar of chloride ions, exactly. H2SO4, what do you suggest? Aha, I get 2 molar of protons plus 1 molar of chloride.
No, Sophie.
Thank you. SO4 2 minus. Thank you very much. People are awake. Hey, that's cool. Yep. This was another question that a lot of people, made a lot of people plummet into depression. Looks pretty simple, but you have to get the concept of that. Now, how do we actually measure the proton concentration? First of all, we measure the proton concentration usually with something called an indicator. It's not the thing that you use in your car. An indicator just simply shows you that something's happening. That you, for example, take the turn and drive into a tree. So you have an indicator. And this indicator measures the proton concentration in something. Can you make these indicators yourself? It's a very, very simple thing that you can do. Take some red cabbage, boil it, and filter the boiled stuff, filter it through a coffee filter. It leaves you usually with a blue or slightly purplish reddish liquid. Right? So next time you cook red cabbage, try that. And then you add, for example, a little bit of vinegar to this blue solution, and it will turn deep blue. Or you can add a little bit of oven cleaner to that solution, which usually contains hydroxide ions, and it will turn bright red. So this is a really nice way to check out whether you have protons in a solution or whether you have hydroxide ions in a solution with an indicator. Now, how can we measure this? And Anton rightly said, we measure it with what is called the pH. And I have to be careful when I say pH, because, sometimes my dentures come out. pH. You want to be careful. What on earth does pH mean? Well, actually, nobody really knows what this P stands for. But rumor has it that it stands for the Latin word pondus. What does pondus mean? Sorry? Potential, yes, it stands for actually weight. I'm surprised you don't know that, because you're dealing with it every single day. A pound, exactly. A pound coin originally was a certain weight. And that was the currency, So if somebody paid you a pound, it meant, give this person a pound of gold or silver. Yeah, bless you. So it usually, in this context, it probably means the weight of hydrogen, the weight of protons in here. But how are we going to do that? Well, of course, we can say if we have a 1 molar solution of something, of HCl, we have 1 molar of protons. This is what we said earlier. But the bioscientists are really a bunch of lazy bastards. And therefore, they decided, let's go for something slightly more complicated. They also like to obfuscate things. And therefore, they brought the definition of the pH. pH is nothing else but the negative logarithm of the proton concentration. And usually, to indicate that it's a concentration, people put it in square brackets like that. OMG, what on earth is that supposed to mean? Let me give you a quick example. Let's say we have 1 molar protons. I can write 1 as 10 to the power of 1 equals 10 to the power of 0. Exactly. Just as a reminder for the log questions that you all did. So, I want the pH of this solution. pH equals minus log of this proton concentration of a 1 molar. And it always has to be in molar. Always has to be in molar. You can't do it with millimolar or micromolar or anything like that. Has to be in molar. So what is minus log of 1? 0. Equals 0. Hey, have a look at that. 10 to the power of 0. Ooh, do you see something here? Do you spot a relationship? Yeah? Here we have 0, here we have a 0. Ah, okay, what about, bless you, what about I have a 0.01 molar concentration of protons? So pH equals minus log of the proton concentration. What's the proton concentration? 0.01 molar. Well, has to be in molar, but the pH doesn't have a unit. Okay, can you put that in your calculator?